It was pretty obvious to us that we needed a video on this this linear actuator. Look, all we really gave people was this exploded assembly, and they got the part numbers, and that's a big help. So we've gotten quite a few emails from teachers saying, here, we need more information to get this linear actuator working. So that's what we're going to do now. So here you go. This is a nice little sort of Will has put out for us. Will, I'll let you talk here for a second, so knock yourself out.
Okay, so right here what we have is just a brand new linear actuator that we put together. It's got the carriage on here, and these are right out of the box, the stepper driver motor. We don't have any connections to it yet. We're just showing the pieces that are required. Now
hold on. Where did you get the linear actuator parts from?
Okay, these are from Open Builds.
Open Builds.
It comes as a complete kit.
Yep.
Now you can buy the linear actuator as a kit, but you have an option, and you want to make sure that you put the option for the stepper motor on there.
What sort of dollars are you talking about for that?
With the stepper motor, it's like $149.
Pretty reasonable enough for a linear actuator.
And
this is a 3D printed part. Okay, what about this?
This is the stepper motor driver, and this will drive the stepper motor. It's a little complicated because it uses serial commands. I think that part is about $250.
Yeah.
That's one of the more expensive parts.
We had to use that part because we wanted to interact with a PLC.
Well, the way it works, the trade-off is how you have the PLC operate versus the stepper motor. This accepts serial commands from the stepper or from the PLC.
Yep.
Now, if you wanted, and you can operate this just with straight out giving it steps and direction, but you need high-speed outputs on the PLC, and the Click PLC doesn't have the high-speed outputs. You can't use relay-type outputs for driving it directly.
So there's two ways of controlling a stepper motor. You can actually give it the steps, which requires a little bit more. I feel like I was able to figure out controlling the stepper motor, which is the serial commands.
Yes.
It's not as complicated. It's easier to do.
Yeah, it's an easy thing to do. It makes this part, it's a trade-off. You either buy more in the PLC or you buy more inside the driver. And this one gives you the option. You can use this one to drive it with steps, but then you need an enhanced version of the PLC.
Okay, I got you. Which we don't have because we were using a low-cost Click. Right. What else do people need to get going?
Okay, so with this, it comes with this cable, and you have to have this cable. This cable has, let me open it up here. It has like a telephone jack, an RJ11 type jack at one end, and then it's got a D sub at the other end. Now, this is the cable that you need to program the driver so it'll work. This is not the operational cable that you're going to need.
What happens if people don't have a serial connector on their laptop or computer?
Okay, so what we need is because everything is USB now, is we have a protocol, well, it's just a simple jumper cable. So we use this to go from the D sub into our computer. And you're most likely going to need that. I haven't seen a computer around that has D subs in quite a long time. So this comes with the driver. You're going to need to buy this at Best Buys or any shop. It's probably about $10.
Serial to USB.
Serial to USB. Now, when you're operational, you're going to need to buy this.
Slow down. I know I got you. So go back to this for a sec.
Okay.
So that cable that you broke out, this is going to connect to your computer.
This connects to the computer. This telephone jack is what connects to the stepper motor, and that connects into the regular jack right here.
Now, can I ask you, is it worth? So this cable is only used when we're setting up this guy. And you do how many times you need to do this?
You need to do this once.
Once, supposedly once. Now, should we do that now, or?
Well, yeah, what we're going to do is we're going to connect everything up. So we're going to have this go into our computer. We're going to put power, and we're going to connect up the signals, which go into these connectors. We have 3 connectors. This connector is for the power. It's 24 volts, and also the drive signals, which go for the stepper motor.
Okay.
There's a second connector that we need, And we use this second connector. This is a digital logic connector.
Did they come with
These connectors come with the drive, the stepper driver motor.
Yep.
And we use this one we take this output signal and we use that when we're in our single sensor setup.
Yep.
Because that'll tell us when the motor is actually stopped.
Right, I feel like, so originally, I'm just going to spin this round just a little bit. All right, and originally we had, I'm going to sit down, we had 4 of these. This is just an inductive proximity sensor. This is just a screw. Whenever the screw drives, whenever this screw is driven and it goes over the inductive proximity sensor, it turns it on. That was our way. We used to have 4 of them at each place. We do. I can show them here.
It stops.
We have 4 of them here, and that's our feedback mechanism. It tells us where we are in the trolley. Will found a way of doing the whole thing with just one, and you're probably asking yourself, how can you get 4 positions of feedback with just one sensor?
Okay, originally, we run the actuator and we stop at the next sensor.
Yep.
Now what we do is we have a signal that comes out of here that tells us when the motor is moving or not moving. So we go to our home position and we say, okay, the first step, you need to go, and this is just the number I'm throwing out, but let's say, and remember, it's 20,000 steps per revolution. So you've got to go quite a number of revolutions to move. So let's say we have to move 200,000 steps. After it makes 200,000 steps, it stops. And then the hopper, will...
So I'm sorry to interrupt you, Will. So number 1, this inductive proximity sensor is the home.
Yeah, this is the home
position
where the cup dispenser is.
Where the cup dispenser is, and you know how many steps it takes to go from the cup dispenser to the hopper. Is that
Right.
fair?
We know exactly how much to go from the cup
Off the top of your mind, do you know what it is in the top of your head?
No, I'd have to look.
You'd have to look at the program.
It's
So-
around
so-
like 500,000 steps.
So we know how many steps it takes to go to each position.
Yes.
Now we don't know what step it's at, do we?
We have no way of knowing what particular step it's on, but we know when it's completed the number of steps.
Yes.
And that's the signal that we use. So we say, okay, go, for instance, 500,000 steps. So it goes there, it stops. It gives us a signal so we know it's stopped.
Now, I hope everyone who is watching this is getting what Will is saying. So essentially, yeah, we know, we can assume that it has done its 500,000 steps because we know when the motor is running and not running.
Yeah.
When we tell the motor to run and it's going, if it's still going, it's not quite there yet. Once the motor turns off, then we know that it's completed that. So that's our feedback.
Yeah, and it's a 24-volt logic signal. It's just like any other sensor would give us a signal into the PLC. It's a signal that goes high when it stops, and when it's moving, when it's driving to the position, that signal is low. So as soon as that signal goes high, we know that we've completed the number of steps that we've wanted.
Now, if you don't like this method is more efficient. It's more effective. You only need to use one sensor. This is the way you should do it. But if they wanted to use 4 inductive proximity sensors to measure feedback, no problem.
Right, and actually, I think, and the sensors aren't that expensive, so if you have 1 or 4, it probably doesn't make a difference. I think it's better to start out with 4 and then move to 1 because the logic actually becomes a little more complicated with 1 sensor. So if you just want to start out from a basic level, it's better to do it with 4 sensors and just stop at the sensor and then just not use the sensors and just start driving from position to position.
Right, now, so I'm following you. I hope anyone who's watching it. Now, can you show them how to set up the SureStep driver?
Right. So the first thing we're going to do is we're going to connect up our cables and we're going to put it into the mode to program this stepper. Now, once we program it, they also, as part of the program, and it's called the SureStep Pro program, and it's something you can download from Automation Direct for free. That allows you to program it, and it also has a little test function where it just drives the motor a little bit back and forth. And once
Will, I'm sorry to interrupt you, but before they start connecting this to a PLC, they have to do this step.
You have to do this to program this. So this is just connecting the driver to the computer. The computer does all the programming, and it makes one very simple, basic functional test. After you have that functional test working, you know that everything is working at this point. So now, when you connect it to the PLC, if you're having problems, it's in the PLC, because you've got the same connections and setups. All you're doing is you're replacing this cable that we're running into our computer with a regular Ethernet cable that runs, well, a regular cable that runs into the PLC. So we're going to program it, and then we're going to test it. And then we're going to have pretty good confidence that this part of it with the driver and the linear actuator is working.
Now, before you do that, if you're trying to actually build this linear actuator, there is a video. We probably should put a video on the description. That comes from Open Builds.
There is a video, and it is very helpful because there is some, and you know, I'm not electrical, I'm not the mechanical, but there is some mechanical adjustments that you have to do because sometimes when you build these, you know, it's noisy from some of the components are too tight, and there is a little bit of adjustments, and the video that they've used to help set this up, they say it's really good and really useful.
Now, do you want to wire this up, or do you want to do this as I'm recording, or
no,
do you want?
I think a little bit of time.
I'll stop this.
What we're going to do is stop and come back in about 5 minutes, and we'll have everything set up, and then we can just walk through the software and take a look at that.
Thanks. Right, so we have the stepper motor, we have the linear actuator, we have the stepper motor driver. I have 24 volts, 0, and then the colors red, green, yellow, blue. Okay, I've taken out this inductive proximity sensor. Will has downloaded the SureStep
Our
Pro.
SureStep. And when it comes up, it's going to give you this error that it's COM1, try COM2. Now, actually, it's going to be neither COM1 or COM2. I'm not sure how old this program is, but what we have to do is we have to go into our device manager and figure out what port we're actually on, because we're going to need that information. So if I get my device manager popping up here.
And this is business as usual with any USB.
Right. So we need to know it's COM3. So COM3 is just the information that we need to get. And that's all we have. Now in here, there's 4 steps. Each of these blocks is one of the steps to program. And actually this last one is just to download to the drive. The first thing you have to do is that you have to call out the drive. Now our drive is the 4850. So you just highlight that. That step is done. Now you go over here to Motion and I/O. Here you select the serial command language.
That's a step I forgot down at the training in Florida, and that's important.
This is really important because here is where you can select pulse and direction, which again our PLC can't do that. We want the serial command language. And here you can just say all of this. Now what we're going to do, choose a function for the output. And we'll talk about this later, but we're going to do it right now. We are going to open it, well, we're going to close it when the motor is moving. So that way, that signal on the output is going to tell us when our stepper motor is moving or when it has completed its steps. Now, we don't need that for what we're doing right now, but further along when we're talking about a single sensor, we're going to need to do that. So we might as well, since we're only going to program it once, let's do it
Baud race
now.
9600.
Everything is fine.
Okay.
That's the only thing that we're changing. So that's fine. The motor itself, it comes up with this size motor. We have a size 23 motor, and we're going to pick the 23055. Now, they do have the size 23 different motors. Now, I don't think, some of these are dual shaft with the Ds at the end, but I don't think it really matters which one we have. It's not an issue of drive, so we've always had the 23055 as the usual one. Now, you leave all these others at the defaults. The only one that we move is This one is for rotor inertia or load inertia, is we just change it from 1 to like 1.4 or 1.2. But 1.4 is pretty good, and there we go. And we're going to leave it at that. This is the only one that we change, and I'm not sure we have to, but it'll give you an error that says, hey, you did not change that, so we just change it anyway. So we're all set. Now, we've done the type of drive, we've done our serial commands, we've got the motor. Now all we have to do is go to download. Now here's where the software is kind of iffy. We are going to go in and we're going to go into COM3, which we know we're trying to program on COM3. And now when we try to download, it usually has a problem, and I'm fairly confident it's with the software. This is the status bar, so this down here will quickly highlight in light
Now,
blue.
Will, what are we downloading to the drive?
We're downloading all these configurations that we just programmed.
Okay.
So we programmed the type of drive, serial commands, and the type of motor that we're driving. So now we're trying to download it to the drive, and it does not want to work. If that was working, you'd see a quick, like cyan colored stripe as a progress bar, and it would just go flash across the screen in like half a second. Usually what I do at this point is, and right now we aren't using the PLC, all we're doing is we're using the power supply from the PLC. So what I'm going to do is turn off the 24 volts. So that's turning off the 24 volts to the drive motor. I'm going to let it sit for about 10 seconds, then I'm going to power it on and try to download once again.
Yep.
And that's all we're trying to do. And I actually think it's in the software, because in their manual it says something about if it doesn't work, turn off the power and retry it. So we're still on COM3, and we'll download again, and there it went. You saw that cyan?
Absolutely.
So now this, I don't know why it works like that. I don't think it's my computer, but now what we can do to test it is if you go in this drive function, it's got something that says self-test, and you just click on it, and it'll tell you the motor is turning a half a revolution in quarter-inch increments. And now you can see that it's actually doing that.
So if it does that, you can assume that this wiring is correct, that you've configured it correctly.
Yeah, the wiring is correct. We're pretty much ready to go with the thing.
That's a good sign.
That's a very good sign.
Okay.
So now the next step is, and this is all you need to do with this part. So we programmed it once. We're not going to program it again unless, we somehow, there is no reason now that it's programmed to ever change the program. So, we're done with this, and now what we're going to do is we're going to disconnect our little test cable, which goes into our computer. So again, we have our little test cable. We've got our little D subminiature to USB. We're just going to get rid of that, and we're going to hook up to our actual PLC. We're going to put in a little simple program.
Now, the PLC is going to be generating the serial commands and sending the serial commands to the
Right.
SureStep driver.
Yeah, the serial commands will come across a cable just like this. Now, the cable that we need.
Now,
for the
some
actual-
people might not know what serial commands are. They're just basically simple text commands.
Yeah, I mean, it's a serial string of commands. Now, what you need when you go, so this cable comes with the stepper driver. The cable that you need operational from the PLC to the driver is a special cable that you have to get from Automation Direct. And the part number on there is an STP-232 RJ12-CBL-2. You have to have that cable. Otherwise, you're not going to be able to run it from the PLC. The other thing about this cable is this cable will have RJ11 connectors at both ends. Now, it's not a straight-through cable. It has one cable marker, and this cable marker is on the drive end. So you have to make sure, and here's the one that says drive end.
Very, very, yeah.
You have to make sure that this is plugged into the drive. If you have this plugged into the PLC, it's not going to work either.
Yep.
So you have to have the right cable, and then you have to have the right end of the cable plugged into the drive.
Yep.
And, you know, if
We're going to set that up now.
yeah, we're going to set that up. It'll take a couple minutes to get that going, but, you know, and then we'll take a quick look at what the serial commands look like and how they get programmed. And, yeah, then we'll see this in operation.
You'll be laughing. All
Yeah.
right?
Okay.
All right, back in a sec. Right, so we're done with the SureStep software. We have, this looks way more complicated than it is. All we're doing is you could get away with just one PLC, power supply. This is connecting to Will's computer. Mm-hmm. This is going directly to the SureStep. We make sure that we have a drive end on that end, and it's just connected in. We're done with the serial cable. This is, we're using the Click software. We have 3 inputs and we have 3 outputs. This is just a serial, it's, what is this? Is this a send command?
Yeah, these are sending serial commands to the stepper driver. And so,
all they're doing really is they're sending that string of text, okay? JS1, the $0D is just a carriage return. Will is going to talk about that, he can do a better job. JS1 is the speed, isn't this? Jog speed.
jog speed.
DI1 is the direction. CJ is commence jogging.
Yeah, that is the thing that actually starts it.
All it's doing is it sends JS1 first, then DI1, and then CJ, and it sends those 3 strings, and it will get it moving. Now, is there anything in behind the scenes that they need to do with this COM port setup?
Well, no. Well, you may
I'll
have
let
to
you
do
have control
something
over
when
here.
this Click PLC is brand new. But for what we're doing right now, the one thing that we have to do is, and for what my setup is, I have to go into Open Network and Internet settings.
Hold on a second now. Where are you doing? Show me that.
Okay, so we're going down to this because right now we have to connect locally. Right now I have the connection would be for a wireless connection. So what I have to do is I have to open up my Network and Sharing Center, and here we click on the Ethernet 3, which again we have this blue cable that connects into the PLC, and what we have, because we're USB, is we have a protocol adapter that goes from USB to Ethernet.
That is, I think that is specific for your computer, what you're showing me there.
Well, again, just like most computers don't have DB9s, nowadays most computers don't have Ethernet.
Understand.
Some do, some don't.
Yeah. So if you have an Ethernet connection, you don't need to do that. But the other thing you can do, though, as part of this Click PLC, there is an Ethernet to USB adapter.
Right, you can get that, and
it's a few extra dollars.
So what we're going to do is we're going to go in here, we're going to look at the properties, and what I have to do is I have to go into my IPv4, I'm going to look at the properties, and here, instead of obtaining an IP address automatically, I'm going to put in a local address. Now, we're just going to put it in, this is a standard private address, so it's the 192.168.0. Now, I can pick anything as this last one. I usually pick 99. And then the subnet mask, we can just pop that in. And that's the only configuration I can do.
Now, do we want to show that to the worldwide people out there?
Yeah, that's fine.
Okay.
Now, because we're using this PLC, and we've used this PLC a lot of times, and I think, and I'm not positive of this, but I think this PLC will come with a configured address of 192.168.0.10. So we want to be on the same network, and all I'm doing is just changing the address here so that it agrees with the address that's in the PLC.
I'll be honest with you, Will. And you're showing them this so they can download code to the Click PLC.
Right.
Now, I'll be honest. I didn't have to do any of this with my laptop, but my laptop has an Ethernet port. So
Well, yeah, we can talk about that. You might have a problem, but you want to make sure you're on the same network.
Okay.
So when we first go in here, we go to the PLC tab on the top, and we say we want to connect to it. Now, it's going to come up, and see how this says good and good. That means we're on the same network. Now, I've got my IP address on 99, which means we're in the same network. Now, it can look for devices outside of this network, but because we put it in the same 192.168.0 network, and this is the address of the PLC, so it is 0-10. So that's why, you know, we make the connection, it's good. So, yeah, Tim is saying that his computer worked automatically. I think the best thing is to put in something, and I'm pretty sure that this is the default PLC address.
No, but yeah, some people, when they see IP addresses, they start to freak. I wouldn't blame them. The other thing you can do, though, is all Will is trying to show you is how to download code to it. We used the USB before. I've seen people use. Do you even know where that USB box is? Do we have it?
Yeah.
You didn't like it.
If I saw it, I would have thrown it away.
You would have thrown it away. That is a way, another way. But all Will is all he's showing you is how to program this ladder logic into the Click PLC.
Right.
Okay,
So now we've just connected to it. Now we go back to the PLC tab, and now we're trying to write the project into the PLC.
Yep.
So we do that, and it comes back. And here, okay, so connect. Maybe I didn't do that before. Maybe we just showed that. Now it comes back, and this is the screen that you want. If this screen comes back in this blue and purple thing, good to go. If it comes back, sometimes some of these screens, if they aren't in the same network, one of these will be, because they're in the same network, this PC is all set up to talk to the PLC. Sometimes it'll come back and one of these will be shadowed out if they're not in the same network. And I think that might be what you were talking about earlier. And then it'll say, do you want to download anyway? You can say yes. But right now we're okay and we're good to go because everything is not grayed out. So we can say okay. Now the first thing it does, you're in run mode, you have to go to stop mode, and then you'll have to download it and change it back to run mode. So now it's downloading into the project, and the transfer is done.
Now,
And again, we just have to put it back in the run mode.
So we have 3 buttons: start, reset, and stop. Okay.
Right.
The only difference between each of the send commands, the second one is
It's minus DI.
minus. So you have
DI minus 1.
DI minus 1, which is the opposite direction.
Right.
So it is the exact same code as this one. All it is changing the direction.
That's right.
And then the last one here is SJ, which is stop jogging.
Yeah.
So Will is going to hit the start button.
Right. So right now, when we hit the start button, it starts moving.
Yeah, and it's going to keep moving.
Keep moving until I hit the stop. Now, we have to make sure that we don't go all the way to the end, because you can jam up the gearing if you go too far.
Yep.
So you want to make sure you don't go all the way to the end.
So before, and maybe the speed, watch the speed as well.
Yeah.
Hit the old stop button for me. Oh, sorry, hit the reset button.
So reset
Yeah.
is going that way. And now, I'll just hit stop for a second, and we can show you if you want to change. So right now, we're at jogging speed 1 for both of them. Now, when I'm going to change this one, if I want to increase the speed, let's just go to jogging speed 3. So I'm going to change that to 3. Now I'm going to say OK.
You're a wild man.
And so all we have to do, again, now all we have to do is say we want to write this project. There's 2 of them. One is write data. You want to make sure it's write project into the PLC. And now we'll have 2 different speeds, so it'll go a little faster, but then you can also see that, it's using one set of code to go one way and another set to go the other way, which...
Let's download the ladder logic. I'm going to stand back, Will.
Okay. So here we're going a little bit faster.
Oh, yeah, that's decent enough.
Now, here's going back the same speed.
Yep. The other thing you could do when you're testing the stepper motors in the code is you could disconnect one side of the coupling until you're kind of confident. If you disconnect one side of the coupling and it takes off at 100 miles an hour, it's not going to damage the linear actuator.
Yeah, the best thing to do is just start it off. Jogging speed 1 is kind of the slowest. I think about 3, maybe 4 is about the fastest you want to go. Okay, so here's our program. What we have is when we hit the start button, we're going to move, this is 500,000 pulses, and at 20,000 revolution, or pulses per revolution, that'll be 25 revolutions of the stepper motor. So it'll drive fairly far, halfway down the linear actuator. And then when we hit the reset, it's going to come all the way back to the homing position. When it hits the homing position, it'll stop. Now, the way we have it set up and what Tim was talking about is when we drive down the linear actuator and the stepper motor completes the 500,000 steps, it's going to light up the green light on our stack light. So I'm going to connect up, and the program's already in there, so all I'm going to do is I'm going to turn on our monitoring. So we can take a look at the signals. Okay, so there's our monitoring. So start is going to move it down towards the end. And we also have it so it drives down a little bit faster than it comes back. So now we've done the number of steps, and our green light is on. So we know that the stepper has completed its mission. Now, when we go back, we're just going to jog back at a speed, and it's going to jog until it sees the home sensor. And when it sees the home sensor, it'll be at the home position, it's going to stop. Okay, now I also had to put in an extra logic gate here because, again, this signal is saying that the stepper is stopped. And originally when I put it in, the green light was on at this position too, so I had to put that the green light is only on when it's not at the home position, when it's at the far sensor. We could easily put a different light on for the home sensor. But I wanted to also show, in our PLC, we have wired up these two LEDs. The top one here, which is X05, is where we showed the signal coming in, and that's the feedback that says the stepper is stopped. So I'm just going to turn it on, and actually what happens, and then one next to it is for the induction sensor for the home position. So when I hit the green button, it's going to move away, and then both LEDs will go out. Now, when it stops driving, the top LED will come back on because it'll stop, and you can kind of hear when it stops. So it stops, that LED comes on, and because we're at the far end, the green lamp also turns on. And the other one isn't on because we're not at the home position. So now when we do it, they'll both turn on, but our green light on the stack light will not turn on because we'll be at the home position. And that's what we have. Now, I just wanted to say, you know, one last thing, and I knew this, but we had a little problem, is when we put in these commands, and this is just the command to jog back home, you know, we have these carriage returns that we have to put in to, you know, it's the termination of a command. So here we're setting the direction, and then we hit the carriage return to say, you know, that's the command for that. And here's the jogging speed, and then this is commence jogging. But when I originally put the code in, even though we're doing stop jogging here, you don't have to add the carriage return here, but you need to put down here that you're using a termination code, and that termination code is $OD, which is, if we look in the ASCII table, is the carriage return code. So if we just look at that, the carriage return code is OD. And so for all these commands, you also have to make sure that the termination code is checked and that it's for OD, which is, you know, our carriage return. Now, you know, you have to put this implicitly in between every instruction, but you also have to make sure that this is checked. And I just wanted to, you know, just elaborate on that a little bit. So that's our little view for our setup that we have right here. And you know, using this, and especially, you know, making sure you're using the edge trigger stuff, you should be able to put together any type of linear actuating that you want to do.